Good morning. I would like to thank Simit and Icarda for having invited us and having deposited your confidence to present on behalf of Bolivia. I am going to share on behalf of the technical team made up by Alejandro Bonifacio, Milton Vilca, Genaro Aroni, and other colleagues that are supporting us. What we've been able to do so far during this execution period in Bolivia, we've been addressing the project actually focusing on weather with a lot of limitation on the South Highlands of Bolivia. So there is interaction between the breeding of llamas, the harvest of quinoa, that it's just a few of the ones that grow in this region, an intervention with a vegetable coverage. Like these are bushes and grasses that grow very slowly due to the climate and soil conditions. So there are interrelationships among these components back and forth and in the same direction. So the approach should be basically on the
salidas y entradas que en algunos
system as a whole, understanding that there are inputs and outputs that are more intense sometimes than that we have in the South Highlands of Bolivia are the droughts, frequent droughts. Since this is an arid zone, a very dry zone, during the year we have only 200 millimeters of rainfall. And also the basins of the soils is low. 0.5% organic matter is the soil cover. So we see the degradation of the soil. Also, there is wind erosion due to high winds during months where it doesn't rain. Also, we have the salinity in some zones, which is a very important concern since these quinoa production zones on the South Highlands are close to the Bruni salt production zones, and we have the plantation of quinoa. Great part of the world there are also low temperatures, so vegetation and crops that actually can grow should be able to resist to low rainfall levels. There are also biotic problems such as larva complexes that attack quinoa, and that's a concern of producers. Within the framework of the project, we've been trying to improve the livestock and agricultural systems, farming systems, trying to establish coverage crops and also having fodder available, producing seeds and seedlings with producers, native species, in order to be used as a soil coverage and also living barriers. The intervention zone of the project is located on the South Highland of Bolivia, department of Potosí, and Oruro, which is the southwest region of Bolivia. And as I was telling you, this is characterized by having altitudes between 3,800 from 4,000 meters above sea level. The annual rainfall 200 millimeters and mean temperature below 10 Celsius degrees on an annual basis. There are sandy zones with low content of organic material and, as I have said, in some cases with salinity problems. Now, speaking of progress, we've been promoting 50 contour barriers in the quinoa fields that have been implemented in these past years. We've been assessing these living barriers that in a quinoa production field, we can have 2, 3, or 4 barriers depending on the surface planted by the farmer. And the length can range between 50 to 100 meters. We have been evaluating that the width of these barriers ranges between 0.48 to 1.5 meters high, and the width is 1.5 to 3.8 meters. This varies depending on the number of rows, 1, 2, or 3. They're mainly native bushes that adapt correctly to the soil and climate conditions. An important problem to address the reforestation project with these bushes for living barriers. It is the collection of seeds and the multiplication, and this is something that we've been doing with 88 producers by training them in terms of the prompt collection of native species seeds and then the multiplication of these seeds. So we have some photographs of the practices that were carried out in order to multiply the bushes and also some grasses, trying to repopulate some grazing zones. In total, in this last project, we have multiplied 10,000 seedlings, and with an agreement with the Ministry of Agriculture, we have actually multiplied 48,000 seedlings, small trees, to be given to the llama breeders or producers. One of the legumes that adapts correctly and they're native of the zone is the wild lupinus. This is the only one that could actually improve the rest or succession of the soil due to the nitrogen fixation, since it's easy to work with this. The seeds actually fall very fast, but it's difficult to collect them because of the fastness in releasing that seed. So we've been working in order to give the producers a chance to improve the resting period by having this legume, which is a lupinus, wild lupinus. So in the few chances to rotate the crops, we can actually improve the properties of the soil. Here we see a quinoa field, which is being, let's say, planted with the lupinus. Once the lupinus is planted, naturally it reproduces and multiplies. In other words, it stays in the soil, and that's important for the fertility management of the soil. Once again, understanding that there are just a few species that can adapt to these harsh conditions and that can have the possibility of fixing nitrogen. Besides, the lupinus is actually eaten by sheep and also the llama. And we have assessed the assessment of the grazing lands, and we see that the health rate of the grazing land is negative. Therefore, that one front to work is the improvement of native grazing lands. And for this, the project has been undertaking some actions such as multiplying small plants in order to give them to the producers so that they can plant them. And the support to the quinoa production, which is the crop which is most frequent in the regions, has benefited 72 producers. We've been working on assessments on the fields in order to see which conservation sustainable practices are being implemented, those that we've been promoting, and how this has an impact in terms of the quinoa yield. This evaluation, for example, shows that as an average, the um, yield is 160 kilos per hectare of quinoa grain, understanding that the normal average in the zone ranges between 500, it's around 500 kilos. So there's an improvement in terms of the yield, production yield, but there's also variabilities, as we can see on the charts. By checking the main municipalities, we see the distribution of the 72 lots of land, and there are some municipalities such as Wari that has mean yields close to 2,000 kilos per hectare, 1 ton, and other places such as the municipality of Uyuni, where the yield was close to 550 kilos per hectare, with the logical spread of each site and producer. There are more than 12 varieties that they're using, and we've been able to evaluate the fact that the Pandela varieties, the Toledo varieties, for example, the Kelu, are the ones that are most outstanding due to their yields. So genetically wise, there is diversity, and within that diversity we can pinpoint some of these varieties or ecotypes that can be better adapted to these conditions. These yields reported have been, let's say, combined with the practices undertaken. Everyone will choose a good seed, 43% in total, and close to 30% use manure, which is the natural fertilizer coming from the llamas mainly, and when more than 30 lots assessed, is more than 70% have living barriers. So this is a good practice. Most of them are working on these living barriers, and 81% of producers actually control insects using natural products, bio inputs, and some traps like pheromones, but not as often. So these are the 4 most outstanding practices that producers are implementing in the field. There are others such as the improved rest with the use of legumes, but a very low percentage still. Another practice is also the vertical, let's say, harvesting or sowing of the land, and that's something that we still need to try in the future. These are some pictures of the assessment work during the data collection process of these more than 70 fields that produce quinoa. You have 5 minutes to finish. Thank you, Sam. So it is always a task to try to promote this knowledge, to spread the progress. With the obvious limitations of the pandemic, we've been trying to comply with our objectives, or meet our objectives, sorry, and also inviting college students, and also with the participation of some technical institutes, because this is a way to involve the new generations on these new alternatives. And what we've been working most on are webinars, cycles of webinars like this one that we are having, where we had the participation of almost 580 people in order to talk about the soil management, water, plant coverage in climate change context for the sector that breeds llamas. We distributed all the publications, and also all these publications received around 500, and well, all these publications were given to 580 people digitally, and it was interesting because we could actually communicate the good work of these publications. Also, they were given physically in some events, in some in-person events mainly, and also we're working on, let's say, private sector alliances. We have signed an agreement in order to carry out more actions, but we will be coordinating also with other projects such as Swiss Contact, which is an inclusive market project within the areas in which we have several neighboring zones. We want to strengthen the practices also with the support of another project which is starting, supported by Japan. Satrex is the name of the project, and Satrep, sorry. And we are still working in order to strengthening these lines of work. And we are also working with organizations of producers, ANAPKI, which is the National Association of Quinoa Producers. It is a renowned organization. And we try also to produce organic quinoa with good practices, something that is actually strengthening our relationships. So this is the end of my presentation. Thank you for your patience and your attention. Thank you, Cresencio. Let me just switch.
So if anybody has any questions, please ask them in the chat or put up your hand if you want to ask them in person. Let me go back again. Y Cresencio, mencionaste entonces 4 tecnologías que son los utilizados. Disculpa, estoy escuchando en inglés, pero estoy en canal de español. ¿Está bien?
Sí, gracias, Sam, sí.
Pues mencionaste selección de semillas, el uso.
You selected the selection of seeds, insect control, and also hedgerows. And also, you mentioned one, which is the production of legumes, and also the resting periods for crop rotation later on. Some technologies are, let's say, embraced by farmers and others not so much. Why? Could you tell us why, or what are the ones that are the best choice? For example, working on the land or on the soil, for example, the challenge is to have minimum sowing of the land, or to have direct seeding, tillage. And this is something that we are introducing with some tests, some, let's say, trials. But maybe we have to do one of more practice. It all depends on how they are facing the quinoa production. It may take longer. Another practice is to improve the crop rotation with the use of legumes. There are just a few ones that are adapted to these extreme conditions of both of climate and soil. And this is the wild lupinus, which is endemic of the neighboring zones to these regions. But there are like 17 producers that have started using this. So when we have been assessing them in situ, we see the practices that producers are using, and the value is quite low. So those that are most frequently used in the land are the use of manure, the hedgerows or living barriers, and also the use of a quality seed or a selected seed, as they call it. And this is always part of a good approach for the crop management, and also the use of larvae or insects. That for quinoa is a problem, but the challenge is to do it naturally, organically, because most of the production in these zones is organic production. So we should not, or they should not use any chemicals. So that's the challenge. There are alternatives such as the use of pheromones for these insects, and also for the use of some bioinsecticides formulated based on biological components or elements. So when you ask some why these are not used, or other, let's say, systems, well, one is the wild lupinus is not giving a lot of seeds. It's actually very difficult to pick up the seeds, to collect the seeds. And in the case of the, let's say, the tillage is a work that will take longer. A final question, and a very fast one. We've heard last time from Santiago, and then the calculations, so that once farmers are adopting new technology for conservation techniques, how can these actually techniques can have an impact on mixed systems between grazing lands for the llamas and also the quinoa production? In your case, have you seen that systems in this zone of the highlands of Bolivia are well integrated, and what's the impact on the use of combined technologies or systems? Are there some gains, some challenges for the adoption of these new technologies, combined technologies? Well, what we've seen regarding the livestock and farming systems are a lack of balance. More or less as of the year 2013-2015, due to the high price of quinoa, great part of the grazing zones and also some zones that were covered with native vegetation were enabled to produce quinoa, motivated by the high prices. So a lot of producers decided to produce more quinoa, actually affecting the livestock systems. So there's a lack of balance with two consequences. On one hand, the decrease in many places of the herds, and also the degradation of the soil, because by enabling the land that were covered naturally with organic material, well, you see, the sustainability of the soil was not kept, since the organic matter was not enough. Now, manure is given by the herds, in this case, the llamas, and there are some limitations, since there are many llamas. In other places, the livestock is kept. So quinoa, but the quinoa in a way is giving back, because the byproduct of quinoa, after harvesting it, all the husks and all have a lot of content of protein contents and minerals. They're called hippie, which is a local name, which is a residue of the harvesting of the quinoa. That's a supplement for the llamas, especially during scarce times. So many times, in terms of in economic terms, we can see some measures.